Hi there, Mike Kossic, CEO of XYZ Interactive. I'm here at the Mega Startup Weekend to talk to some of these robotics companies about essentially utilizing our technology for some of their products and businesses. Now, one of the things that we found is robotics is an interesting market, but the volumes aren't necessarily there yet. So part of what we need to do is understand when that's going to happen, when should we start really paying attention to this market. We have a custom method of ranging. So our technology allows for really precise location of objects without the cost associated with some of the other visual systems. So the Connect is a wonderful technology. It gives you 300,000 points of depth information. You'll see it in a lot of the things that are around here, and it's really captured the eye of the consumer. So fastest selling consumer electronics product now in history. That's great, and it's really brought this type of touchless interaction into the forefront of people's minds for consumer products around them. So if you take a module like this is commonly used in a lot of robotics companies. It's from Sharp. It's a linear distance sensor. We can take our technology and replicate it, and you'll see using a lot less components, not using a Fresnel lens, to create an equivalent and replacement sensor for a lot less cost. So we can even compete with Sharp at low volume. However, even this is not a really attractive market. It's only about 10 million units a year across the entire Sharp family. So what interests us is when we start to extend this technology. So what you have here is some of those electronics encapsulated in a block, and essentially it's two transmitters, one receiver. So you get not only the distance, but you get what we call a gesture sensor. So if you take a look at this simple display here, to engage the sensor, you can just put your hand up, right? And then what you see is as you raise and lower your hand, you're going to get that distance, okay? So that gives you that precise distance away, and it's very, very reactive. But what's really, you want to see that again? Okay, so you hover to engage. So essentially, it knows that your hand is there and not moving. You want to engage it. That's how you turn it on. There's a few different ways of engaging on and off a gesture-based system. You can use a hover to select, or you can use a wave, so it detects a particular pattern. So hover to select is the dominant one because it's used by Connect. So this is the simple up and down and distance that's output here. But what's interesting as well as now we've added 1 penny of cost, and you get, as you see here, this what is a gesture sensor. So it's going to give you how far to the right or left you are. So the further you are away, the faster the scroll speed, right? Now, our company is XYZ, but companies don't buy data streams, they buy interactions. So it's mostly the gestures that are actually capturing the attention of most of the product designers. So what we've done is we've built in essentially gesture detection into a lot of our products. So if you look here, you see when you swipe, it's going to give you that swipe gesture from a distance, right? So now you can imagine a simple sensor like this put into a faucet. You can control temperature by where your hand is over the faucet. Or in a light switch, you swipe up for on, down for off, dim with how far away your hand is.
So it has gestures built in.
Yeah.
And you just map those to a function.
Yeah, or iPod docks, or a whole bunch of simple consumer electronics. Now, the Connect is, again, a wonderful technology. This will give you a lot less resolution, but it allows us access into those types of use cases where you're not going to put a camera for a few reasons. Cost, power, so we're very low power compared to a camera. Privacy issues, you're not going to stick a camera in a bathroom. And even the Connect is still an $18, $19 bill of materials. Ours, you're using totally off-the-shelf components. So IR transmitters and receivers, we're actually a software company. So we license our technology to OEMs who are interested in solving particular use cases, right? So for touchless and gesture control.
What was that?
This is, as you can imagine, robotics isn't where tablets is in terms of volume, right? I mean, all of these guys here at this weekend, including myself, know that that's an eventuality. But just the numbers in the tablet market are astounding. So, 100 million tablets are going to be sold next year, 1 billion tablets by 2015. There's obviously, we want to get not only to future versions of the tablets, but into peripherals for those tablets. So it's a very attractive market. So this type of configuration information will give you, if we can get this much information off of 2 transmitters and 1 receiver, we're going to get a lot more information off of a system like this, right?
So they would just build it into tablets to have gesture control.
Potentially. So one of the issues with current technologies like the Kinect is there's a blind spot close to the screen.
Okay.
So the 2 things in mobile that need to be solved for gesture technology to really kind of come in, if you think about future 3D interfaces, 5 fingers near the screen. So the 2 things that need to be solved are power usage, right, and what we call the blind spot, or being able to work right close to the screen. So that's very important. So this is a simple array-based version of our technology for demoing potential. Now I have it configured in a certain mode now to use an active transmitter. So this is more of a stylus type of model. So rather than having all of the transmitters and receivers in the same location and run off the same chip, we actually now break them apart. So this technology is actually how we started thinking about this market, from an active technology, so active transmitters and receivers. So you want to use this for when you want more distance, or you want objects to follow around other objects. You can use this in robotics, for swarm robotics, for putting let's say we put some in these little Sphero things, which are all over the place now, and you put a little transmitter on your little brother and sister, and all the balls follow them around, right? So to do that at low cost rather than using high-cost computer vision techniques. So the active version of the technology, I'm going to get this working. So what you see here is you get very, very reactive. You have 1 transmitter, you get a pointing device. So as you go further away, that ball gets smaller and smaller, and as you get closer, it gets bigger. Now, with 1 transmitter, a change in X position can't be distinguished between a change in X and a change in yaw. You need 3 transmitters to do that. When you get that, you get a full vector, you get X, Y, Z, roll, pitch, yaw. I'm going to need to reconfigure this into passive mode, which essentially means it's going to be looking for reflections. So although this is a really cool technology and probably very useful in robotics, most of the use cases that capture the consumer hearts and minds are the ones where you don't have to, hold something else in your hand, right? Because the advantages of our technology is once you have these passive receivers built into whatever it might be, light switches, curtains, robots, or whatever, you can add this active system and you have these built-in receivers. So let me give you a very simple analogy. You walk into Home Depot and you buy a 3-pack of dimmer switches from Lutron, and they include a remote control in there. You're going to do one of 2 things. You're going to either pick it up, you're going to say, oh no, not another remote control, and you're going to chuck it in the bin, or you're going to say, hey, that's cool, and you're going to use that remote control. So think of it as an add-on to our technology that you can't do with other competing technologies. So again, from a tablet perspective, this is really important for the stylus use case. So that tablet market is big enough for the stylus to make a lot of sense. So I've got to reprogram this now, which is going to take me a few minutes. So you might want to stop that